Okay, here's the second part to 10.2, 10.3 notes. Ran out of time. I apologize. Had to make this into 2 segments. So let's finish up then. The area of circle A is 250.75 square inches. So that's the entire area of this circle over here. The area of sector BAC is 45 square inches. Find the indicated measure to the nearest hundredth. So it says find the radius of circle A. Well, if we think about what the equation for a circle is, or for the area of a circle, it's pi r squared. I'm going to get my brain working. Pi r squared equals 250.75 inches. So we can set up an equation like this. So in order to find what the radius is, I first have to divide by pi. Remember, pi is just a number, so 3.14. And that gives me the radius squared equals, let's use our calculator here. We got a lot of lag today on the internet, sorry. Okay, so 250.75 divided by pi, and it's 79.81. It says measure to, or round to the nearest hundredth, so we'll go 79.8. Okay, and then we have to take the square root of both sides. So r equals the square root of that number. So I can just go second square root. This one's second, and then the x squared button is my square root. And then I can put of the answer. I'm going to put second answer so it's more exact, because that will give me that number. And that's 8.9. So the radius of that circle would be 8.9. The circumference of circle A. So we got to think about our equation for circumference is 2 pi times the radius. Now, I found the radius up here was 8.9, so I can just substitute that into this equation. So the circumference would be 2 pi times 8.9. And I just put that in my calculator. And I get 2 pi times 8.9. 55.9 would be my circumference. Okay, and then arc BAC, we're going to have to find that by looking here. The area of the sector was 45 square inches. So how are we going to find the measure of this arc right here? So on this one, I'm going to use my formula for the area of a sector, and that is going to be the angle measure over 360 times pi r squared. Now I know r, so I should substitute it in right now. And that's going to equal 45 square inches. So if I substitute 8.9 in for r, then I can solve this problem, solving for trying to get that isolated, theta. So if I take pi times r squared and I multiply that out, I get pi times 8.9 squared. It's 248.8. So this portion right here is 248.8. So I'm going to rewrite this as 248.8 times theta, I'll just write it right there, over 360 equals 45. So in order to solve for theta now, I just have to multiply by the reciprocal of this on both sides. And that gives me 65.1 degrees. So that means that the arc is also 65.1 degrees. If this angle right here is 65.1, this arc is also 65.1. Number 9, calculate the area of each segment. Round your answer to the nearest tenth. So number 9 says, if the radius of the circle is 6 centimeters, what is the area of this shaded segment? So I'm looking for this. So the first thing I need to do is find the area of the sector, and then I'm going to subtract the area of the triangle here. So the area of the sector would be 90 over 360, which reduces to 1/4, times pi times the radius squared, and the radius is 6, so it'd be pi times 6 squared, which is 36. So this reduces to 36 pi over 4, which if I leave my answer in terms of pi is going to be 9 pi. However, it does say in the instructions up here to round your answer to the nearest tenth. So we will multiply out 9 pi, and we get 28.3 if we round to the nearest tenth. So 28.3 is the area of my sector. I can write right here to remind myself. Now let's find the area of the triangle. So it's just 1/2 base times height. So it'll be 1/2 6 times 6, or 36. So that is 18 centimeters. So if I now just subtract 28.3 subtract 18 centimeters, I'm going to have 10.3 centimeters for the area of that little sector right there. Number 10 is exactly like number 9, except for it gives us a diameter. So I need to convert that to the radius. So if the diameter is 44, see if we can get this to focus just a little bit better. If the diameter is 44, then the radius is 22. I'm going to do that one exactly like I did number 9. So I'm going to let you try number 10 on your own. And number 11 is a bit of a challenge problem. I'm going to show you how to set it up. Then I want you to see if you can figure out how to work through the steps on your own. In circle O, below, the measure of arc AB is 90 degrees. So this arc right here is 90 degrees, which means this angle is 90. Already marked for us. If the area of the segment is 6 pi minus 32 square feet, what is the length of the radius of circle O? So we basically have to go backwards when we went up here, because when we were finished taking the area of the sector minus the area of the triangle, we found the area of the shaded region. So here, it tells me the area of the shaded region is 16 pi minus 32, so that's what I'm going to set up my equation to equal. And then on this side I have 1/4, that's 90 over 360 reduced to 1/4, pi radius squared, minus, now this is the equation of to find the area of a triangle, so it's 1/2 the base times the height. Well, the base and the height are both just the radius, so 1/2 r squared. If I simplify this, what I first did was multiplied everything by 4, both sides of the equation by 4, get rid of my fractions, and then I can pull out a radius squared. So now the next step is to divide both sides by pi minus 2. And then I have to take the square root of that. So I kind of showed you how to do it. I mean, I basically showed you how to do it. I just didn't find the answer for you, but that's how you would solve that problem. It takes a lot of extra thinking on that one to apply what we know. So that's the end of the notes.